Now the next chapter that we have to do over here is factorization. So the factorization, in this chapter we have polynomials and we have factorization of polynomials that we are doing in this chapter. Okay, so there is division of polynomials and etc, etc. So we will be covering polynomials. So first of all, you need to know what polynomials and its related terms are. So what is a polynomial? Any expression that is written in the form of a naught x raised to power n plus a1 x raised to power n minus 1 plus a2 into x raised to power n minus 2, so on to a n minus 1 into x plus a n. This means that there are a naught to a n terms. This expression, any expression that is written like this, is a polynomial. Okay, now what happens is, this is a naught to a of n, right? So how many terms are there in this? There are a naught to a n, so n plus 1 number of terms in this, if none of a naught to a n is equal to 0. If any one of them is equal to 0, so that term is gone, right? So what are the conditions for this to be a polynomial? The conditions are that all of these a naught, a1, a2 and so on to a n should be real numbers, and n should be a non-negative integer. What is n? N is this raised to power n and this n. Both of these n's are same, and this n should be a real number, and all of these should be, this n should be a positive integer, and a naught to a n, all these numbers should be real numbers. So that is the only condition for this expression to be a polynomial. Okay, now I'll explain you what are the related terms of a polynomial, and then I'll give you examples of polynomials. Okay, first of all, degree of polynomial. What is a degree? Degree is the highest power of x, right? So in this expression, the degree is n. If degree is n, if and only if a naught is not equal to 0. If a naught is not equal to 0, then the highest power of n in this expression is, the highest power of x in this expression is n, right? So if a naught is not equal to 0, the degree is n. Okay, what is a constant term? The constant term is the term which does not have x in this an. Okay, so this is very easy. The constant term is ax. What are the coefficients? Okay, coefficients are all of these terms, right? A naught, a1, a2, a3, so on to an. So a naught, a1, a2, a3 and so on. These are all the coefficients. What is the leading term and the leading coefficient? Leading term and the leading coefficients are the first term, or the term with the highest power of x again. Okay, so in this, if a naught is not equal to 0, if a naught is not equal to 0, the leading term is a naught x raised to power n, right? This is the leading term. Okay, and the leading coefficient is a naught. So this is the leading term, okay, and this is the leading coefficient. Right? So now we know what are the leading terms and leading coefficients. And then we have a zero polynomial. Zero polynomial is that polynomial in which all the coefficients are 0. That means that all the terms a naught, a1, a2 and so on to an are 0 in this polynomial. And what is a constant polynomial is in which a naught, a1, a2 and so on to a of n minus 1 are equal to 0. That means that there is only one term, that is an, that is the constant term, and that polynomial is called the constant polynomial. Okay, so now you know what a polynomial is and what are its related terms. right? Now I'm erasing this video. If you have to check it again, just rewind the video and go through it again. And I hope you've noted it all down, right? So now I'll be giving you a few examples of polynomials. Okay, just hold on for a bit. First of all, I've just erased this by mistake. So this will be a of n minus 1 x plus a n equal to 0. Okay, so this is the basic form of a polynomial, right? So now tell me 7x plus 2 equal to 0. This is a linear polynomial. Why? Highest degree of x is equal to 1. So this is a linear polynomial, right? Now let's tell me now 7x square plus 2x plus 3 equal to 0. What is the degree? Degree is 2. This is called a quadratic polynomial. Okay, now tell me 7x cube plus 2x square plus 3x plus 4 equal to 0. This is the degree to this polynomial is 3. So this is a cubic polynomial. Okay, and so on. If we go on like 7x raised to power 4 plus 2x cube plus 3x square plus 4x plus 5 equal to 0. What is the degree? It is degree 4. Okay, now tell me what is x equal to 7. This is again a linear polynomial. Why? Because this can be written as 7 minus x equal to 0. So the highest power of x is 1. What is a constant polynomial then? 7. This is a constant polynomial. Okay, so now we have a broad idea about what polynomials are. Linear, quadratic, cubic, degree 4, again linear, and this is a constant polynomial. So we know what polynomials are, right? Now let's move on to equality of two polynomials, right? Now this is, in general, we've written two polynomials, right? This is, the first is fx and the second is gx. Now if fx and gx have to be equal, which is written as fx equal to gx, what are the conditions for that? The conditions for that are, first of all, the degree of fx should be equal to the degree of gx. That means that n should be equal to m. Okay, that means the degree of fx should be equal to the degree of gx. That means n should be equal to m. And the second and the most important one is that all the corresponding coefficients should be equal. That means that a0 should be equal to b0, a1 should be equal to b1, a2 should be equal to b2, and so on. an minus 1 should be equal to bm minus 1, and an should be equal to abm. Sorry, this here I've written it wrong. This is b of m minus 1 and bm. I'm really sorry for this. Okay, so this means that all the corresponding coefficients should be equal, which means that ai should be equal to bi. Done? Did you understand this? These are the two very basic and very important and the only conditions for equality of two polynomials, which is written as fx is equal to gx. And the conditions are the degree should be same and all the corresponding coefficients should be equal. Okay. Now let's come to the division algorithm for polynomials. We know what the division algorithm is for normal numbers, right? That is equal to dividend is equal to divisor into quotient plus remainder. It is the same for polynomials. Dividend that is fx is equal to the divisor, that is gx, into the quotient, that is qx, plus the remainder, that is rx. The only condition is that rx should either be equal to 0. In that case, gx and qx both are the factors of fx, right? Do you understand this, right? Because it is completely divided. Fx can be completely written as gx into qx. So both of these are the factors of fx, right? Either that, in that case, rx is equal to 0, or the degree of rx should be less than the degree of gx. These are the conditions for the division algorithm. Again, I will be covering questions based on the division algorithm later, and this is just the theory for you guys to understand. Just re-watch the theory lecture once again after solving the questions. It is very easy. It will just take 10 minutes of yours. Just re-watch the theory lectures once again after solving all the questions. Okay. Now the last part of this video is remainder theorem. What is the remainder theorem? Remainder theorem says if a polynomial fx is divided by x minus alpha, then the remainder is f alpha. Now again, this is just a normal, I'm just explaining it to you just like this. This is just what the statement says. I will explain this to you via examples, because in questions how it will be asked is that verify the remainder theorem for this division. Okay, in that you will be given the value of fx and you will be given the value of alpha. So all you have to do is satisfy the remainder theorem. This is how the questions are going to be. So the remainder theorem says if a polynomial fx is divided by x minus alpha, then the remainder is f of alpha, right? So this is all the theory that I have for right now. What you have to do is you have to watch this theory lecture, solve all the questions, watch all the videos on the questions, and then re-watch this one for more clarification.